This is from Chapter 3 of Stats by Bock, Velleman, and Veaux. It's problems 19 and 21. And the idea here is we've got data from acceptance decisions for magnet schools for the Houston Independent School District, HISD. And the first questions are just kind of procedural questions, thinking about percentages of various kinds of data you can get from a table like this. And then 21 is a more interesting question, really trying to make a conclusion. Does it appear that the admissions decisions are made independent of ethnicity? So let's do it in the order that it is in the book. We'll do the calculations first. And I'm going to skirt around violating one of their principles. It's maybe creating a little bit of a complicated table at the end, but I'll try to make it pretty simple. So here's the data that they give us. They actually give us the totals, the row totals and the column totals. I just wanted to illustrate that even if you didn't have that, it's easy to do that on a program like this. This is Microsoft Excel, by the way. So we could do equals, that means it's a formula, the sum of, and then we just highlight these cells, and then that gives us the total. Now a cool thing is that if we copy that and we paste it down here, it actually says, instead of up here, the formula is C2 to H2. That's these cells. When you copy it, it's smart enough to say, oh, I think you probably mean relative to this cell, the same positions. The ones 3 units to the left, 2 units to the left, 1 unit to the left. So it actually changed it to Z4 to H4. And if I copy and paste it here, I just did a Control V for paste, I get the sums here. Now these are in the book, and I can double check them. They are correct from the book. Okay. Similarly here, I could do the sum equals the sum of well, let's see. It's a little dangerous to put stuff in here because it's probably going to see these cells. I've got these extra cells for my own devious purposes here. So probably let's just put it in equals this plus this plus this. I don't want to use the sum function here. 931, that's the correct number. Now I can just copy and paste that over here, and I can even paste it over to here to get the grand total. So that's stuff you wouldn't have to do in the actual book problem, but it's kind of cool that Excel does that in a simple way. So now, for example, what percent of all applicants were Asian? So it's really, the book is very clear about this. You can't just say what percent are Asian. It's the percent of what total. Okay, of all applicants, that's the total here. And then Asian, that's the total Asian here. Okay, so that is, we want a percentage of this in its total column. So it's going to be a column percentage, and I'm going to put column percentages in this little sub box. So we're just going to do equals this divided by this. Now I could have just put in the numbers, but it's cool to do it in terms of clicking, because then if I realize that these numbers were wrong, if I change this to a 295 or something, or if I change one of these numbers, it would automatically update it. Okay, so the percentage of Asians among all applicants is 17%. And so that's, I'm just going to take that, I'm going to say this equals this. So notice I'm not putting in any numbers beyond these raw numbers that were already in the table. It's all calculations based on these numbers, references to other cells and calculations. Okay, so among all the applicants, 1755, the 292 represents 17%. I'm not so much interested in teaching you Excel here, but it's a really good skill. But mainly the interesting thing is all these different kinds of numbers that you could get and the meanings of these numbers. Okay, what percent of the students accepted were Asian? Excuse me. What percent of the students accepted? Okay, so accepted, that's another column. So we want another column percentage. So let's say this equals the 110 accepted Asians divided by the total of accepted. So that's 12%. Okay, that's interesting. It's different from 17. That might mean something. Okay, what percent of Asians? Now this is interesting. So now it's going to be of the total Asians were accepted. So the of Asians says our total pool for this particular question is the 292. This is going to be a row percentage, and I'm going to put that here. For accepted Asians, the 110, out of the total Asians. So that's going to be equals accepted Asians divided by total Asians. Okay. So I didn't really note it down anywhere, and this is one reason maybe this table is going to be confusing in a minute. These left things are the column percentages, and these are the row percentages. I think of a good way to actually, maybe I should color code it or something. Okay, what percent? Oh yeah, and let's see, I forgot to do the 12. So this we'll just copy this, refer to that guy, and then this is equals this guy. Okay, just wanted to have them here as the answers to the questions. What % of all students were accepted? Okay, here's the all, here's accepted. Okay, so that's a row percentage, the 931 over the 1755. I'm going to put that here, equals 931 divided by 1755. Now, to answer this question, all you really need to do is do these calculations. You don't need to put this in Excel to use the technology, but I figured I'd show it since I'm doing it on the computer anyway. And then I'm going to just copy that, or refer to that right there. Okay, so 53% of students in general are accepted. Only 38% of Asians were accepted. That might mean something in terms of the question here. Let's go ahead, since they didn't really ask, but let's go ahead and fill out some of the rest of this stuff. I can do this. A column total, again, it's this divided by this guy, and I could do the white equals this divided by this guy. I could do this in a copy and paste fashion. Let's see, this will work. If I copy this and paste this, that should work, because the pattern is the same. Okay, wow. So of the waitlisted people, you're likely to find, if you take a random waitlisted person, of the 300 waitlist, most of those folks are white. That's interesting. Okay, and then I think I can even, let's copy this and paste this, and copy and paste, and copy and paste. So those are the column totals. Okay, so so these are, if you're looking at the accepted pool, what are the percentages? If you're looking at the waitlisted pool, what are the percentages? Black, Asian, white. If you're looking at the turned away pool. That might not be the most interesting thing. Oh, and let's see, waitlisted, we could do the total. Oh, if you do the total here, this is just going to be 100%. This is going to be silly, but equals this divided by itself. You could put that if you want. Of the accepted pool, how many were accepted? Well, it's 100%. So that isn't terribly interesting. But we could still put that in here if we want. So I could just copy and paste that. Okay. Now what about the row totals? Like this guy, this was of the total Asians, how many were accepted? That might be more interesting. You're probably more likely to say, I want a condition. So these are conditional kinds of percentages. I want a condition on, I know the person I'm thinking about is Asian. What's the probability that they were accepted? So let's see. I think I can copy. Ooh, I don't know if I can copy and paste. I can copy and paste this guy vertically. Okay. So that's very interesting. That of the black and Hispanic applicants, the vast majority are accepted. Asian, it's a little over a third. White, it's very similar, but just it's essentially the same percentage. Okay. So here we could look at the wait list equals this divided by this. So that's waitlisted black and Hispanic over total black and Hispanic, and then I can copy and paste that down here. This should be okay. And so this is of the waitlisted percentage. So you can see that the category that has biggest waitlist is the whites. Not too surprising given that 84 we already saw. And then we could do equals this divided by this, and I can copy and paste that. Okay, so turned away, it's very unlikely to be turned away if you're black and Hispanic. Of course, it's vanishingly unlikely to be turned away or waitlisted if you're black and Hispanic. But it's pretty likely to be turned away if you're Asian. Now, turned away and waitlisted, combining these things, it's pretty big for both Asian and white. Now, I could look at these guys. Let's see. Column totals equals 517 over 1755. Oh, yeah, and that's the same thing as this guy and this. Okay, oops, just kidding. I did the wrong thing. Divided by this. There we go. And then, of course, I could do this divided by itself, which is kind of silly. And then I could look at the row totals. Those are going to be uninteresting as well. That's this divided by itself. I just want to be really complete. Okay, all these are going to be 100%. Okay, just checking. So now is where probably this is an overly complicated table, but we can extract parts out of it that are interesting. So if we wanted to know, I'm looking at only black and Hispanic. I'll just go ahead and highlight those, and I just want to look at the percentages accepted, waitlisted, or turned away. I just go ahead and look at these three numbers, and they add up to 100%. So I could maybe highlight just those. Come on. And if you ignore kind of all the other stuff, then we get an interesting piece of information from there. And we could do that with column totals or row totals. So we're getting interesting information about conditionals. These guys, remember, are called marginal percentages. That if I don't worry too much about this classification with these three categories, but I won't worry about black, Hispanic versus Asian versus white, then these guys, maybe use a different color, these guys are interesting numbers. So remember, these are called marginals, and then these guys are called conditionals because they're saying specifically, if I am accepted, then what's the chance I'm black and Hispanic? That's this guy. If I'm black and Hispanic, what's the chance I'm accepted? That's these ones. Okay, so let's go down and look at this information and really try to make a conclusion. Does it appear that the admissions decisions are made independent of ethnicity? So I want to use this think, show, tell rubric that they used. Think, so we want to figure out what data are we given and what question are we trying to answer. We are given, and we want to use complete sentences, we are given admissions data for HISD magnet schools separated out by ethnicity. We want to decide if the admissions decisions are made independent of ethnicity. Well, how would we do that? To do that, we can compare the conditional distributions of the admission decision variable. That's the categorical variable, which is either admitted, waitlisted, or turned away, and we can condition on the three ethnicities. Okay. And that just totally didn't work at all. Wrap text. There we go. Ooh, it's still kind of big. Okay. Didn't quite have enough room for that. Okay. So, show. So what I've done here is I've separated out the rows so that Excel can understand this a little bit better. Because what I want to do is I want to look at these numbers. I want to draw a picture. As they say in the book, the first three rules are draw a picture, draw a picture, draw a picture. So what I'm going to do is I'm going to insert a pie chart. A pie chart is appropriate here because these are non-overlapping quantities. Oops, that's not what I wanted to do. Let's move it up here a little bit. These are non-overlapping categories, and so a pie chart is going to be very appropriate. Okay. So, oh, I didn't want total. That's not very good. Let's. It's getting confused because I included the total. I just want these three. There we go. So let's insert a pie chart again. Just a regular pie chart. Okay, so here's the, let's see. Okay, so for black and Hispanic, I wanted to make that smaller. No, let's make it smaller. We've got the majority are accepted and a few are turned away. Nobody's waitlisted. Okay, and that's what we were seeing from the percentages before. Now I just highlight these 6, make a pie chart again, ordinary pie chart, and we're going to move it over and make it a little smaller to fit. Okay, here, Asian, it's a very different looking pie chart. It's a much smaller blue and a fairly amount of orange and a lot of green. And here, the white, oops, don't want the total. We're going to insert a pie chart one more time, 2D pie chart, and we're going to put it down here and make it a little smaller. And here, whoa. So here, that's pretty similar to the Asian pie chart. If I wanted to really tease out the difference between what's going on with the Asians and whites, I might want bar charts or some sort of other comparison. Although you can tell that the waitlisted is bigger here. For some reason, the mix between waitlisted and turned away is a bit different. But we've already seen the accepted percentage. Remember, that's the percentage here. 38, 36. That's very, very similar. Okay. And then we could even compare to the total. This is the bottom of the original chart. And we can make a pie chart of that. And for that, the total is kind of in between. It's got a pretty big accepted. It's more than 50%. definitely different from the white or Asian percentage, but a lot smaller than for the black and Hispanic. Okay, so it's pretty clear, because these pie charts are this pie chart is so different from these two, that it really is dependent on ethnicity. Okay, so tell, we can say by comparing the pie charts for black and Hispanic to the other two ethnicities, we can see that the decision is dependent on ethnicity. Black and Hispanic students are much more likely to be admitted. Okay, and undoubtedly that's intentional. That's probably part of the design of this magnet program, is to support black and Hispanic students. Okay.